Your eyes are changing the physical world right now. Every time you measure a quantum particle, you force it to pick a side, and before you looked, it genuinely existed in multiple states at once. This has been confirmed in labs thousands of times over the past century, and the implications reach far beyond physics. The way you direct your attention may be shaping more of your reality than you've ever calculated. In 1927, a physicist named Niels Bohr presented an idea so strange that even Einstein spent the rest of his life trying to prove it wrong. Bohr's claim was simple on the surface. Subatomic particles, electrons, photons, the building blocks of everything you can touch, behave differently when someone is watching. Before observation, a particle exists in what physicists call a superposition. It occupies multiple possible states simultaneously. The moment you measure it, that cloud of possibilities collapses into one definite outcome. Einstein hated this. He famously asked whether the moon ceases to exist when nobody is looking at it. Fair question. But experiment after experiment sided with Bohr. And the most famous of those experiments is still running in physics labs today. The double-slit experiment sounds deceptively simple. Fire particles, photons or electrons, at a barrier with two narrow slits. Behind the barrier, place a detector screen. When nobody is tracking which slit each particle passes through, the particles create an interference pattern on the screen. Bands of light and dark, like ripples crossing in a pond. The particles behave like waves, passing through both slits simultaneously and interfering with themselves. That alone is strange enough, a single particle going through two doors at once. But when researchers added a detector at the slits to observe which path each particle chose, the interference pattern vanished. The particles started behaving like tiny bullets, passing through one slit or the other, producing two simple clusters on the screen. The act of looking changed the outcome. The particles seemed to know it was being watched. So what's actually happening at the physical level? This is where it gets precise. Measurement requires interaction. To detect which slit a particle passes through, you have to bounce something off it, a photon, an electromagnetic field, some form of energy. That interaction disturbs the particle's quantum state. The superposition is fragile. Any entanglement with the measuring device causes what physicists call decoherence. The wave function doesn't mystically respond to human consciousness. It responds to physical interaction with any system complex enough to count as a measurement. This distinction matters enormously. Pop science often frames the observer effect as proof that human consciousness controls reality. Physicists themselves are more careful. The observer in quantum mechanics can be a machine in an empty room. Consciousness is optional. Physical interaction is mandatory. But, and this is the part worth sitting with, the philosophical question hasn't been settled. Physicists John Wheeler designed a variation of the double-slit experiment in the 1970s called the delayed choice experiment. In Wheeler's version, the decision to observe which path the particle takes is made after the particle has already passed through the slits. The result? The particle's behavior changes retroactively, as if the future measurement reached backward in time and told the particle how to behave in the past. Wheeler actually ran a version of this experiment using light from distant quasars, billions of light years away. Photons that had been traveling for billions of years still had their behavior determined by a measurement choice made in a lab, moments before they arrived. Billions of years of travel, and the last millisecond decided everything. Sit with that for a second. A decision made now apparently influences a particle's behavior in the deep past. The timeline of cause and effect gets slippery at the quantum level, in ways that classical physics can't accommodate. Now, several interpretations compete to explain these results. The Copenhagen interpretation says the wave function is a complete description of reality, and measurement genuinely collapses it. The many worlds interpretation says every possible outcome actually occurs. The universe splits, and you only experience one branch. Decoherence theory describes how quantum effects wash out at larger scales through environmental interaction. Each framework handles the math. The experiments can't currently distinguish between them. What they all agree on, where you point your measurement apparatus, determines what you find. The question shapes the answer at the most basic level of physical reality. And this is where the bridge to daily experience becomes less metaphorical than you'd expect. Researchers in cognitive psychology have documented something that echoes the observer effect at the human scale. It's called selective attention, and the mechanism is more aggressive than the name suggests. Your brain processes roughly 11 million bits of sensory information per second. Your conscious mind handles about 50. That means your awareness is selecting 1/200,000th of available reality at any given moment. The classic demonstration is the invisible gorilla experiment from 1990, run at Harvard. Participants watched a video of people passing a basketball and were told to count the passes. Midway through, a person in a gorilla suit walked into the frame, beat their chest, and walked off. Half the participants never saw the gorilla. Their attention was focused on counting, and the gorilla, fully visible center screen, for 9 full seconds, simply ceased to exist in their conscious experience. The parallel to quantum measurement is striking. The gorilla was always there, the information was available, but the act of focusing on one variable made another variable vanish from the observer's reality. Your brain does this constantly. Every hour, every minute, the filter you apply to your experience determines what shows up. Focus on threats, and your day fills with evidence of danger. Focus on opportunities, and the same environment produces a different dataset. The raw input stays constant, the observation protocol changes the output. Psychologists studying goal-directed attention have found that people who write down specific objectives literally see relevant information that others miss. In one study, participants primed with a particular goal identified related objects in a cluttered visual scene faster and more accurately than control groups using the same scene. Their eyes moved differently. Their brains flagged different signals as important. Same room, different observer, different reality. This carries an uncomfortable weight. If your focus functions as a filter, this aggressive, then distraction carries a cost beyond lost productivity. Every hour spent passively scrolling, every meeting where your attention fragments across 3 screens, every evening absorbed in content you didn't choose, these aren't neutral activities. They're measurement choices. You're collapsing possibility into a specific, narrow experience and discarding the rest. A quantum physicist would say, the experiment you set up determines the results you get. You cannot observe wave-like possibility and particle-like certainty simultaneously. The measurement choice excludes alternatives by definition. Your daily attention works on the same principle. When you focus deeply on a creative problem, solutions surface that were invisible during shallow scanning. When you give full attention to a conversation, you catch micro-expressions and subtext that evaporate under divided attention. The information was there either way. Your observation apparatus, your focused mind, is what converts possibility into experience. Critics would rightly push back here. Quantum effects operate at subatomic scales. Neurons are massive by comparison. Drawing a direct causal line from quantum superposition to human focus involves a category error that serious physicists would flag immediately. The math of decoherence shows quantum effects washing out long before they reach brainscale structures. That critique holds. The connection is analogical, not causal. Your attention doesn't literally collapse wave functions in the objects you look at, but the structural parallel that the act of observation constrains what can appear operates at both scales through different mechanisms. Quantum measurement constrains particle behavior through physical interaction. Focused attention constrains conscious experience through neural filtering. Different machinery, same architecture, and the practical implication survives the critique intact. What you measure is what you get. In a lab, this is physics. In your morning, this is the difference between a day that happened to you and a day you shaped by choosing where to look. Wheeler, the same physicist who designed the delayed choice experiment, spent his final years chasing a phrase he coined, "it from bit." His argument was that information, measurement, observation, the asking of yes or no questions, is the foundation of physical reality itself. Every particle, every field, every force derives its existence from the observations that define it. Reality, at bottom, is participatory. You aren't watching the universe from outside. Your observations are part of the structure. The double-slit experiment has been replicated with objects of increasing size. Molecules of 60 carbon atoms, molecules of over 800 atoms. Each time, the same result. Observe the path and the interference vanishes. Look away and possibility returns. The boundary where quantum behavior ends and classical behavior begins keeps retreating the harder physicists look for it. Which leaves one question that neither physics nor psychology has fully answered. If observation shapes outcome at every scale we've tested, from photons to gorillas to the goals you write on a sticky note, then the most consequential decision you make each morning has nothing to do with your to-do list. It's the decision about what to measure, where to aim the instrument of your attention before the day collapses into a single fixed result. Every other choice follows from that one.